We now have all of the Git tools installed, and it is time for our first cloning of our Hello World repository. So log into GitHub, go to the Hello World project, and you should see this screen. Now, over here to the right, you'll see the clone or download. We're going to go ahead and we're going to be cloning, so we're going to need the URL. So go ahead and copy that to your clipboard by clicking the little clipboard right there. And then first thing, we're going to learn how to clone a Git repository using the terminal or command line first. And that's the Git Bash Terminal that was installed with Git when we installed it through the executable. So go ahead and open up the Windows menu. You should see it here in your recently added applications. If you don't see it there, scroll down to the G's and you should see Git. If you open that folder, you'll see the exact same applications here. So go ahead and click on Git Bash, and that should open up the Git Terminal. I'm going to make this big so that we can see everything. Now, on a Windows machine, there's a lot of security and file access restrictions and all kinds of user-specific file permissions that happen when you're doing software development. And so I like to make sure that I am in a place on my computer where I'm not going to run into a ton of restrictions and issues when I'm doing software development. So on Windows machines, normally what I do is I go to the C drive, which if we open up Windows Explorer and we go right to the C drive, we will see it's right here where we've got Windows, users, program files, all that kind of stuff. And you see here I've got a dev folder. Now let's go ahead and delete it really quick so that you guys can see how I'm going to do this. So in the C drive, the root of the C drive is where I want to be. And so in a command line, which is a whole different lesson in and of itself, in the command line, we do cd, which is change directory, and I want to go to the C drive, so I'm doing C:. When I hit enter, you'll now see that I am in the C drive. It shows up right there. If I do ls, it lists all of the directories and files in there. And so I am going to create a folder where I do all of my development, where I set up all of my projects so that they aren't restricted by the user's folder. So right here in the center of the C drive, right at the top of the C drive, I like to create a directory. So I'm going to do make dir, so make directory, and I'm just going to call it dev. And if I do ls again and I list the contents of the directory, we are going to see that I now have a dev folder, which was not here before. So to go into that dev folder, that's where I'm going to want to clone my repository, which is going to create a folder for my Hello World project. So I'm going to change directory, and I'm going to go into the dev directory. And now you'll see on my path in the terminal, I am now in /c/dev. And if I do a list contents, you're going to see that it has nothing in there. And if we go back to our Explorer, we can see I now have a dev folder. Nothing's in there. Now, this is where we clone our repository. And if we remember, cloning is taking the repository that's on the remote server, and we are taking that entire repository, everything that's in it, as well as all of the changes that have happened to it, and we are downloading that complete repository to our local machine. So the command for that is going to be Git Clone, and then you pass in the URL to that repository. Now we copied that to our clipboard, so we should be able to, oh, looks like I copied my old path to it. So let's go back, copy it, go back to our terminal, go ahead and paste it in there. And so you should have Git Clone and then the URL to your repository, your Hello World repository. I hit enter. It goes through the process of cloning. Now, because it's a public repository, meaning anybody can clone it, it doesn't ask you for a username or password. It simply clones the repository for you. So now if we list the contents of the dev directory, we're going to see it now has a Hello World directory in it. So let's go ahead and change directories, and let's go to our Hello World directory, and let's go ahead and list the contents. And you'll see when we set up that Hello World repository, we chose to add a license to it. We also chose to have a README file, and you can see both of those files are in there. So those were copied down with the repository onto our local machine. So now let's jump back to something we talked about early on, and let's open up our Explorer to do that. Inside of our Hello World, we've got our license, we've got our README, and we've got a hidden file for Git, right? So in here, license and the README, these are your project files, and the Hello World folder is actually your working directory. So let's go ahead and let's pull up one of those documents we had up earlier. So let's go with the source code management model. I'm going to go ahead and open that up in Windows Explorer or Internet Explorer. Here we go. Close that. All right. Now, when we went through this process and we looked at it, we saw that we have the repository cloned to our local machine, and we have the repository itself, which holds all of the branches as well as all of the changes that have ever happened to the code in those branches. And then we have the working directory. Well, this right here, when we go to our C drive, dev, and our Hello World, this right here is actually this entire container right here. And that's, I say the entire container because in it, it holds all of the files that are in the working directory. In other words, everything that we edit and modify using our editor and that our development server might run against, all shows up here. And then there are hidden files in here. So let's show all hidden files. This right here, this Git folder that is a hidden folder, it is actually the full repository. And it is the folder in which the Git service and tools actually track changes to everything that's in our working directory. So the Hello World repository that downloaded is both the working directory and holds the entire Git repository as a hidden folder with hidden files in it. So if we turn off those hidden files, now it's just like we're just in this working directory right here. All right, so hopefully that helps. So let's jump back. All right, so what we're going to do now is we're going to walk through a really simple situation where we modify something in the repository, and then after we modify that in the repository, we're going to see how Git tracks those changes and what we need to do to get those changes committed back to our repository. So here, we're making our changes in the working directory using our IDE. And when we're done working in our working directory, Git has kept track that we've made changes to those files, but those changes have not actually been committed to our local repository in that hidden folder. They're still just sitting here in our working directory, which means if something happens, if our working directory gets messed up or deleted, those changes are not saved, and they definitely have not been pushed back to the central repository. So let's walk through really quick how we do all of our committing and modifying of files locally, and then we'll jump into how do we push changes back up to the central repository or the remote repository. So let's leave our terminal open. We'll go to our Hello World, and then I'm just going to go ahead and open it up in Visual Studio. Oops, it opened up on my Mac. All right, here we go. Visual Studio 2017. I'm going to go ahead and open it up. And then from Visual Studio, I'm going to go ahead and I'm going to open up my project folder. So let's go ahead and open up a folder. Take a minute for some reason. There we go. Now we did it in our C drive so that we don't have to worry about user-specific permissions. Go to Dev, click on that folder, select the folder. Now our working directory has now been opened up in Visual Studio. If you look at the Solution Explorer over here, sometimes it's a little tab over here. You have to click it, put a pin in it. Now you've got it up there. You'll see we've got the 3 files that we created initially when we set up our repository. We've got our git ignore, which is that file, we talked about it. It's the file that contains a list of all the different file extensions or types of files that we actually don't want Git to worry about. And a lot of those have to do with Visual Studio Solutions, because when you create a solution, you get a .vs folder, as you see right here. And in here, it creates a SQLite database for the project, and it holds a whole bunch of stuff that only Visual Studio cares about, stuff that probably doesn't belong in your project itself. So in here, the git ignore, it actually specifies everything that Git shouldn't pay attention to. All right. So now we've got our license. This is a generic open source license. We said it was an unlicensed project when we created it. We'll leave that one alone. No reason to edit the license. Now we go ahead and look at the README. And this has just some auto information put into it when we created our repository. So let's go ahead and update this so we can actually see some changes that we've made to our source when we work with Git itself. So I've just removed that description. I'm going to go ahead and using Markdown, we're going to go ahead and add a description header. And I'm going to say, this is my first project using source control through Git. Now when I click save on that, I have made a modification to the file. You can see Visual Studio actually recognizes it because it's integrated with Git. It understands Git. And you'll see this file has a modification to it. It's been saved. Now, if we open up our terminal and we say Git right here, we're going to get a list of commands. So these are all the commands that Git understands, and we can use it to kind of review what has happened to our files inside of our working directory right now. So here, some of the important ones to look at are clone. We already used it. Init is used when we create a local repository that doesn't go to the cloud or to a local server or anything like that. It's just when you're using it on your local machine. That's a different one we can talk about later. Add to add files, move, rename, all that kind of stuff. Remove files. And then you've got other important ones. grep is really good when you're looking for stuff, trying to find patterns in files or file names. Branch is important for when we're creating branches. Checkout. Commit is really big for when we are committing the changes we make to our working directory and we're trying to put them back into the repository. Diff when we're trying to find changes between files or differences between files. Merge is really important, and tag and rebase. And then fetch, pull, and push, and we'll get into the use of those in a minute. So let's do a git status, and let's see what's happened. So git status, what it does is it says, Git, tell me everything that's happened to my working directory. And if you notice, it says, these are changes that have been, these are modifications that have happened to files in your working directory, but they have not yet been staged for a commit to the repository. Now, odd wording, it's common wording in source control, but you might not quite get it. What this means is a change has been made to a file, but I have not yet told Git that I want to keep that change. Git just knows that a change was made. Now, Git won't commit a change until I tell it, yes, I want that change, and then it becomes part of a change set, and it is staged for commit. And then committing is when we actually take all those changes and we push them to our local repository, or we add them to our current repository as an actual change set, if that makes sense. All right, so right here, we modified our README file. I definitely want to keep it. So I'm going to say git add, and I'm going to use a period. The period is the wild card. It just says any files that have been changed, I'm good with. Let's go ahead and add those to our change set and stage them for commit. So git add dot. If you don't use the dot and there's only a specific file or files that you want to stage for commit, in other words, you want them to be part of your change set, you would actually have to put in the file path to that file in order to add it. So I'm just doing git add and the period. So now it went ahead and it added the readme file changes to my change set, and it's staged for commit. So if I do git status again, you're now going to see, instead of in red where it says modified readme, now it's in green and it says changes to be committed instead of changes not staged for commit. So now Git doesn't just know about the file that's been changed. Git is now aware that this is a change you really want to keep, and it's now part of your change set. All right. So with that, once you've added the changes to your change set, they still are not a part of the actual repository yet. They're still sitting here in the working directory, and they are staged for commit, but they aren't pushed up into the master yet, which is the branch we're currently in, until we actually execute the git commit and we give it a message so that it knows why we changed that particular source. So let's go ahead and do that really quick in the command line. So let's do that first. So we're going to say git status, just so we can see what we had again. We changed the readme file. So we're going to say git commit -m, and in quotes, we're going to go ahead and type our commit message. Now, it's really important and most of the time mandatory that when a developer makes a commit, you give a description as to what all was done and why. That way there's context recorded around the changes that were made. So here I updated the README, I gave it a description and a much more descriptive description, and I gave it a description header. So I'm just going to say README updated to include description. And then I'm going to go ahead and hit enter. Now, the first time you use Git on a fresh machine where you've just barely installed it, it's not going to know who you are. It's not going to know your name, your email address. And so it's going to have a problem with that, because when we commit source changes to a repository, it's important that we know who made the change, not just why they made the change, but who actually made it. Now you have two options. You can set the email and name by project. So if you're using an email and a name that's different for open source projects or for your portfolio, you may want to set the the name and the email different for a project. If you're working for a company and everything you do is specific to that company, you're probably just going to set it globally. And that's using this global flag right here. So you can omit the global flag and it will just be for this project, or you can use the global flag and Git will always assume that whatever email and name you provide is going to be the name and email that it should be used on any repository that you've cloned. So being that I work on a whole bunch of stuff, I'm going to go ahead and omit the global, and I'm going to make it specific to this particular project because I'm using my Neumont email address. So I'm going to say git config, I'm going to say user.email, and then I'm going to go ahead and use my tclark@neumont.edu, and then I'm going to do git config user.name, and I'm going to go ahead and say Tim Clark. I'm going to hit enter. And now that Git knows who I am, it now has the information it needs to actually make the commit to the repository. Because before it was a fatal error right here. In other words, the commit I tried to do right here did not actually go through because it didn't know who I was. So now I'm going to go ahead and redo that command. So you can actually use your up and down arrows in order to get to commands that you typed before. So I'm going to say git commit -m, and then I'm going to give it my description. I'm going to hit enter. And now it knows who I am. It tagged that change set with my email address and my name. And now those changes are actually now up here in my local repository, and they have actually been committed. Now, if we go back and we actually look at our repository right here and we refresh it, we'll see that my README, the last time it was changed was 2 hours ago, but I just barely made a change and committed it. So you'd think that's wrong. But the reality is that we have not yet pushed from our local copy of the repository to the remote copy of our repository. So to do that, what we need to do is we need to go to our Git Bash, and then we need to now push it to the remote server. So if we do a git status, we'll see that there are no longer changes because we've already taken that working set and we already pushed it into our local repository. And so everything's good between our working directory right here and our repository. And now we want to go ahead and push it up to the central repository. Now, it is common practice, and we went through this when we went through this actual diagram in a previous video. It is very important that every single developer do a git pull and check for conflicts before they try to push to the server. And what a git pull does is it takes everything that's in the branch that you're currently in, well, actually it takes the entire repository, pulls down all change sets that have happened since the last time you pulled it down, updates all of your branches, and then if you've already committed to your local branches, it'll tell you if there are any conflicts, and then you'll have to go ahead and rectify those conflicts. Being that we're the only developer working in this repository, in other words, we don't have any other teammates, there really shouldn't be any issues. So we'll go ahead and go with standard practice, and we'll say git pull. And it's already up to date. In other words, no change sets have been pushed to the remote server during the time that we've been doing this because we don't have anybody else working on the project. So because of that, we don't have any conflicts. So everything that we've committed to our local repository is good to go. We can go ahead and push that up to the remote server. So if we say git push, now it's going to go ahead and it's going to attempt to push to GitHub. Now, because we're trying to push to a project, we need to be somebody who has rights to push to the repository. We made it a public repository, which means anybody can clone it, but that does not give everybody permission to push to it or make changes to the repo. You still have to be somebody who has been approved to make changes to the repository. Now, being that we're the author and we have our GitHub, we just go ahead and put in our GitHub email address, the one we used to set up our account, and then our password that we used. And then we just go ahead and log in. And now it knows who we are. Our change sets have our email and identity on them, and everything has now been pushed up to the remote repository. So if we go back to our GitHub, you'll see last change was 2 hours ago. If we refresh, we should actually see it updated 4 minutes ago. So here we can see the README change. Now, if you notice, that's 4 minutes ago, but I just barely pushed it. Well, this is the last time that file was changed, not the last time I pushed to the server. So you'll see right here that it's keeping track of the last time the file was modified in the last change set, not the last time that somebody pushed to the server. So here we've gone through cloning a repository, the working directory, making modifications, adding change sets to, or adding files to a change set, in other words, staging them for commit, committing them to our local repository, and then pushing those changes up to our remote repository.